In this video, we are going to do adding real numbers, and then we'll come obviously subtracting and multiplying of real numbers. But before we move to these operations, I would like to introduce you the classification of real numbers, of all numbers at all. Okay, all numbers that exist in the world, we call them real numbers. Then, real numbers are separating into rational numbers and irrational numbers. Okay, rational numbers are the numbers you can represent in the form of fractions. Okay, so let's say 4/5 or negative 4.55. The decimal points, when they repeat constantly, these ones, if the ones that don't repeat, let's say 0.2 cannot be rational numbers, or 9.565656 also considered as a rational numbers, which means you divide endless and it's repeating. Next, it can be also, let's say, some regular 7/1. Okay, irrational numbers, it can be these letters, mathematical letters pi, mathematical letter e, square root, 10, and decimal notation that we divide endless, 2, 5, 3, 1, 4, 6, 7, and so on. They can divide endless if they are not repeating. These ones, numbers we call rational. Square root 2, okay, radical 4 of 9, those are irrational numbers. Next, so part of rational numbers we call integers. Integers, it can be -4, positive 10, square root of let's say 25, because it's also a whole number, right? I mean, integer, positive 5 comes out. What else? -3, for example, right? 0, also considered as a integer. So positive part of integer we consider as the positive whole numbers with zeros we consider as a whole numbers. And that includes 0, 1, 2, 3, 4, and so on. And part of whole numbers, it's a natural numbers. Those are same whole numbers without 0. 1, 2, 3, and continuation. Okay, so integers are positive and negative numbers. Whole part numbers we consider from 0 all the way to positive whole numbers, and natural ones, same whole numbers without 0. Okay, all right, once we have this classification, let's solve problem. Not problem, but classify. Okay, we have, let's say, -6. So what we can say about -6? Is -6 integer? We are checking. Yes, -6 is integer. Next, -6, is it rational? Yes, because I can represent as a -6/1, right? As a fraction. So yes, rational. Is negative 6 irrational? No, because in the set of irrational numbers, we included mathematical letters and square roots that are not coming out as a whole number. If it would be square root 25, yes, it would be integer and rational number and so on. But as an irrational number, it cannot happen, so it's not an irrational. And lastly, is it real? Yes, because as you see, both ellipsoids are included in real numbers. All numbers are real numbers. So yes, real numbers. Okay, let's do one more example. What pick up there? Let me see. Let's take the same pi. Okay. Well, we take pi. All right. Let's take pi. Is it integer? No, it's not integer because you can see integer is in separate ellipsoid. So it's irrational. So it's not integer. Is it rational? No, it's not, because rational in the yellow ellipsoid, right? And integer in the blue. So not rational, not irrational. Is it a rational number? Yes, because it's in the pink color ellipsoid. Irrational. And lastly, is it real number? As we know, all numbers are real. Okay. Question number 3. Move this up. The average depth of a certain ocean is 12,586 feet below the surface of ocean. Okay. Full stop. Is this number with plus or minus sign? Okay, since we are talking below the surface, this is our surface, and it's going to be below, right? So 12,586. So it's going to be minus. Yes? Okay. Question number 4. So we have 7. What is going to be the additive inverse? The additive inverse is going to be negative. Let me see. Additive inverse is negative 7. Pretty simple, but if you don't know, it always seems to be difficult. At the minute you know, everything becomes easy. Next, find the additive inverse. Let me make it. Okay, number 5. Find the additive inverse of negative 7.76. So additive inverse is going to be positive 7.76. Question number 6. Okay. Absolute value of negative 2.3. Absolute value always come out positive, right? So it's going to be positive 2.3. Question number 7. Absolute value of fraction f over 8 over 11, it's going to be 8 over 11. Next, what do we have here? Addition. We are adding negative 4, adding another negative 4. Okay, let me write down the table of addition and subtraction of real numbers. Okay, so let me make a line here. First one, second one, third one. Oops, well, forget it, I didn't mean arrow. And this one. So, first term, second term. Here we do operation. Here gonna be result, the sign of result. And I guess that's it. So I can clean this. Okay, and write down the sign of result. Okay, let me start. So if both signs are positive or both signs are negative, the operation we do is addition. Okay, in both cases we are adding addition. And the result is going to be, if both numbers, both terms are positive, there is nothing to choose. That means it's going to be positive. If both signs are negative, that means nothing to choose. It's going to be negative. Now, next one. Signs are different. Positive, negative, negative, positive. So if signs are different, we do subtraction, period. And here subtraction. But the sign of result, it's going to be for both cases, it's going to be the sign of bigger absolute value, meaning positive part, okay? You take positive number. I'll explain in a minute. Absolute value. So let me bring example here. So I have positive 3, positive 5. For both of them are positive. We put addition. So it's going to be 8. We are adding and sign is positive. We have it. Next subtraction. I have negative 3, negative 5. I'm still adding 8 and put sign of subtraction, right? Now I'm using plus and minus. Okay, I put positive 3, negative 5. What we do? Subtracting. So 5 minus 3 is 2. And we are using the sign of biggest absolute value. Why we are talking absolute value? That means you drop negative for this 5 and you take 3 and 5. 5 is bigger number, right, than 3. And then you use the sign of that 5. It's negative. 5 is negative, then 2 is going to be negative. Now, if I use negative 3, positive 5, again, I'm subtracting. It's still going to be 2. And then I use the sign of biggest absolute value. We're dropping negative sign of 3, so take 3 and 5. 5 is bigger number, right? It's 5 is carrying plus. That means 2 is going to be plus. That's what I meant. So we have here number 8. We have negative 4. I don't even need this sign here, this parenthesis. Negative 4 plus negative 4. What do we have it? It's the same thing if I write down negative 4, negative 4. So negative, negative, we need to add, which is 8. And both of them are negative. We are going to put here negative. Okay, question number 9. So question number 9, what do we have? Negative 90 plus negative 40. I don't know why they put this plus, but we definitely don't need it. It's going to be negative 90, negative 40. So both of them are negative, which is this case, right? Okay. And negative 90 plus 40 is going to be 130 because we are adding, and both of them negative, sign going to be negative. Question number 10. What do we have? Question number 10. We have negative 3/17 plus negative 8/17. Okay, I'm dropping positive sign. Negative 3/17, negative 8/17. Negative, negative. So we are going to add, right? Here is the case. Negative, negative, right? Let me write down 1, 2, 3, 4 so I can use it. Which one I'm using? 1, 2, 3, 4. So we are using second case. Negative, negative. We are going to add, since denominator is the same, all we do, add numerator. 8 plus 3, 11. And we are using negative sign, right? Okay. Number, which one? Number 11. So what do we have here? Negative 3/5 plus 2/9. We are going to use here negative, positive for the case number 4. So we need to subtract, right? Okay, to subtract, a common denominator is going to be what? A negative 3/5 and positive 2/9. So 5 and 9 common denominator is going to be 45, which means here multiply by 9, here multiply by 5, right? And we are getting negative 27/45 plus 10/45. So since we have plus minus, minus plus, case 4, we need to subtract, right? So 27 minus 10 is going to be 17, yes? Denominator stays the same. And bigger absolute value with the same denominator, between two fractions, bigger is the one that has a greater numerator, if denominators are the same. So one more time, with the same denominator, the fraction with the greater numerator, absolute value of numerator, because negative 27 would be smaller, but 27 is greater. So it's going to be 27 is greater than 10, and 27 has negative. We put negative sign here. Question number 12. (0.8) plus negative 0.7, which means 0.8 minus 0.7. Well, this is nothing even to explain. 0.8 minus 0.7 equals 0.1. And if we follow the rules, it's going to be case number 3. Positive, negative, we subtract. We got 0.1, and we use the sign of bigger number, and bigger number is 0.8, right? So it's positive, therefore it's the 0.1 is positive. Okay, number 13. So we have negative 1.5 plus negative 3.86. Okay, negative 1.5 minus 3.86. 86. So negative, negative, which is case number 2, right? So we need to add. So 1.5 plus 3.86. So since first number doesn't have the second decimal, so the second decimal just write down there. And then 5 plus 8, it's going to be 13, 1 in mind. And decimal point here, 1 plus 3 is 4, and 1 we have 5. Okay. Let me clean this mess. So 5.36. Now, when both of them negative, case number 2, result is going to be negative. Number 14. $16 plus negative 20. You don't need this plus, so you just straight to 16 minus 20. We have, what is our case? Plus and minus, case number 3, right? So we need to subtract. 20 minus 16 is 4, and we're using the sign of bigger absolute value. Bigger absolute value is 20, its sign is negative, we put negative. Okay. Next one, number 15. What do we have? Negative 96 plus 176. Okay? So we have negative, positive. It's case number 4, which means we need to subtract 176 minus 96. It's going to be 0. 17 minus 9 is 8. Here is 0, so 80. And we use the sign of bigger absolute values. The 176 is plus, so it's going to be plus. Okay? Number 16. Let me see what we have. All right, so we have negative 11 plus 7 plus negative 4. So we're writing down negative 11 plus 7 minus 4. So negative 11 plus 7, it's at the case number 4, we subtract with sign negative because 11 is negative. So it's going to be negative 4, and then negative 4, negative 1 more negative 4, negative, negative, case 2. So we add and use negative sign. So negative 4, it's going to be negative 8. Okay? And the last question we are going to do, number 17. We have 34 plus negative 19 plus 9 and plus negative 26. Okay, let's rewrite. 34 minus 19 plus 9 minus 26. Okay, let's go slow. So 34 minus 19, it's just like a regular arithmetical operation. There is nothing else to do. It's going to be 15, right? Plus 9 minus 26. 15 plus 9, it's going to be 24. 24 minus 26, and this is going to be equal negative 2. Okie dokie, we are done with this the assignments. Moving to next one.